Okay, so today we'll start from question number 4 of exercise 10.3. Okay, so this is class 11 and we are doing a straight line exercise 10.4. Up to question number 13 we have solved. So today we'll start from question number 14. Okay, so just have a look on the question. It says that find the coordinate of the foot of the perpendiculars. Find the coordinate of the foot of the perpendicular from the points -1, 3 to the line 3x minus 4y minus 16 equal to 0. Okay, so you have a straight line whose equation is 3x minus 4y, 3x minus 4y minus 16 equal to 0, or you can write is equal to 16, and one point is here whose coordinate is -1, 3. We have to find the foot of the perpendicular, the coordinate of the foot of the perpendicular. Okay, we have to find the coordinate of this point, and it is given that this line is perpendicular to the given line. How to find the coordinate of the foot of the perpendicular? Okay, so let us consider, let the foot of the perpendicular is suppose h comma k. We are considering the coordinate of this point is h comma k. Okay, now look, this point h comma k is lie on this straight line. This point h comma k is lie on the straight line 3x minus 4y is equal to 16. That means this straight line will be satisfied by this point. So we can write 3h minus 4k is equal to 16. This is our equation number 1. Okay, first condition is formed. Now we have to find another condition. Okay, now look, as this line and this line are perpendicular. Okay, so first we will find the slope of this line. So two end point is given, one is -1, 3 and one is h comma k. So what is the slope of the line joining the points -1, 3 and h comma k. So we have a formula that m1 is equal to y2 minus y1, that is k minus 1 divided by x2 minus x1, that is h minus or minus y2 minus y1 divided by x2 minus x1. So this is the slope of this line. Okay, and we will also have to find the slope of this line. Okay, so given that equation of this line is 3x minus 4y is equal to 16, which means 4y is equal to 3x minus 16. That means y equal to 3 by 4x minus 4. So from this equation, can you tell me what will be the slope of the line? From this equation, can you tell me what will be the slope of this line? Slope of the line, y equal to 3 by 4x minus 4. So what is the slope of the line? 3 by 4. Very good. So slope of the line, if I consider the slope of the line is m2. So slope of the line, slope of 3x minus 4y is equal to 16 is m2 is equal to 3 by 4. Now as this line and this line are perpendicular to each other, so we have a formula that m1 into m2 is equal to -1. So just multiply this into this, so the result will be equal to -1. I have to rub the board. Okay, so I am rubbing from here. So one equation is this, 3h minus 4k is equal to 16. This is our equation number 1. Okay, I am rubbing this. and as the lines are perpendicular, so we have m1 into m2 that is equal to minus 1, which imply put the value m1 equal to k minus 3 by h plus 1 into m2 means 3 by 4, that will be equal to minus 1. Okay. Now just do the calculation. You have another linear equation in two variables. So that means if I multiply it, a 3k minus 9 by a 4h plus 4, that is equal to minus 1, which implies a 4h minus plus 4, that is equal to minus 3k plus 9 after multiplying, after doing the cross multiplication, which implies 4h plus 3k is equal to 5. This is our equation number 2. Now look, equation number 1 and this is equation number 2. This equation number 1 and equation number 2 is a pair of linear equation in two variable, and I hope you can solve the equations, isn't it? We have various process. We can use the elimination method, cross multiplication method, okay, or comparison method. You can it will be 3k. Oh, yes, sorry, that is 3k. 4h plus 3k is equal to 5. Okay, now just solve the equation, okay, and find the value of h and k. So this h and k will give you the coordinate of the foot of the perpendiculars. Now tell me, can you solve it by yourself, the remaining part? Then I will skip the question. We'll go to the next question. I hope you can now solve it. Yes, sir? Okay, very good. So now we are going to the next question. Now we'll do question number, we have done question number 14, and after 14 we will do question number 16. Okay, after 14 we will do question number 16. Okay, so just read the question. Just read the question. Question number 16 is, a P and Q are the length of the perpendiculars from the origin to the lines x cos theta minus y sin theta equal to k cos 2 theta, and another line is x sec theta plus y cosec theta equal to k respectively. Then prove that p square plus 4q square equal to k square. Okay, so write the two equations. One equation is x cos theta minus y sin theta is equal to k into cos 2 theta. This is our first equation, and the second equation is x sec theta plus y cosec theta is equal to k, and P1 or P2, P and Q are the length of the perpendicular from the origin. So that means this is our equation number 2, this is equation number 2. Now P equal to length of the perpendicular to equation number 1 from origin, isn't it? P is the length of the perpendicular from the origin. So what will be the value of P? So P will be 0 cos theta. Do you know the formula to find the length of the perpendicular from a point to a given straight line? Otherwise I will show you the formula first. I have already discussed it. If you know the formula, then we will apply the formula. Otherwise I will write the formula here. Do you want to know the formula, or you know it? Do you know the formula? Okay, so put the formula. So 0 into cos theta minus 0 into sin theta minus k cos theta cos 2 theta divided by under root of r of cos square theta plus sin square theta and mod of this. This is the value of p. So, which will be k cos 2 theta divided by the root over of sin square theta plus cos square theta is equal to 1, isn't it? Root over of sin square theta plus cos square theta is equal to 1. So, the final answer will be k cos 2 theta by root over of 1, that is k cos 2 theta. This is the value of p. Okay, so p is known. Now we have to find the distance of the second line from the origin. We have to find the distance of the second line from the origin. Now q equal to distance of equation number 2 from the origin, and apply the formula. So it is modulus of 0 into sec theta plus 0 into cosec theta minus k by under root over of sec square theta plus cosec square theta, isn't it? 0 into cosec theta plus 0 into cosec theta minus k by root over of sec square theta minus cos square theta. That means it will be k by under root over of sec square theta plus cosec square theta. So value of p and value of q are known. Now we have to prove that p square plus 4q square equal to k square. So write the left hand side. So I'm rubbing this portion. Now find the value of p square plus 4q square. P square plus 4q square, and we have to prove this value will be equal to k square. Clear? Okay. So now just apply the formula. So p square means the value of p is here, that is k cos theta whole square, k cos 2 theta whole square, plus q square means square of this k by under root over of sec square theta plus cosec square theta and whole square. Okay, which means now just do the calculation, you will get the answer. Right hand side will be equal to 1. Okay, so that is k square cos square 2 theta plus this is k square by sec square theta plus cosec square theta, which implies k square. If I take k square common here, so okay, k square cos square 2 theta plus k square by, now sec means 1 by cos square, 1 by cos square theta, and cosec means 1 by sin square theta, and 4 is there, this 4. Okay, which means k square into cos square 2 theta plus 4k square divided by do the LCM. So LCM will be sin square theta into cos square theta. It will be sin square theta plus cos square theta, and we know that the sin square theta plus cos square theta is equal to 1, which means which will imply that k square cos square theta plus 4k square sin square theta cos square theta. Now if I take k square common from here, so it will be cos square theta, and 4 sin square theta cos square theta can be written in the form 2 sin theta cos theta whole square, isn't it? That means k square into this is cos square theta plus, now tell me the formula of 2 sin theta cos theta. Do you know the formula? What is the formula of 2 sin theta cos theta? Sin theta cos theta, 2 into sin theta cos theta. What is the formula of 2 sin theta cos theta? That is sin 2 theta. So sin square 2 theta. Now cos square theta plus cos square, this is 2 theta. Okay. So cos square 2 theta plus sin square 2 theta, that will be equal to 1. So k square into 1, that means k square. So finally we get p square plus 4q square, that is equal to k square, and hence proved. Okay. So question number 16 is also completed, isn't it? Do you have any problem? Do you have any problem? Otherwise, we will go to the next question. Okay, so let's move to the next question. Okay, so our next question will be question number 18. Question number 18. Question number 18 is, if P is the length of the perpendicular from the origin to the line whose intercept on the axis are A and B, then show that 1 by P square, 1 by P square is equal to 1 by A square plus 1 by B square. 1 by P square equal to 1 by A square plus 1 by B square. Okay, so let's start it. This is the a set of rectangular axis, okay, perpendicular to each other. Okay, so this is a set of rectangular axis. A straight line intersect the x axis and y axis at a distance a and b unit. So this distance is a unit and this distance is b unit. Okay, and p is the length of the perpendicular from the origin to the line. Then we have to prove that 1 by p square is equal to 1 by a square plus 1 by b square. Okay, now look, if the line make an intercept a and b with the x axis and y axis, then what will be the equation of the line? Okay, so we will write the equation of the line. The equation of the line having intercepts A and B unit on the axis is, the equation is x by A plus y by B is equal to 1. I think you are very well known formula. This is x by A plus y by B is equal to 1. This is called the intercepting form of a straight line. Now do the LCM. So LCM will be AB. So that will be BX plus AY is equal to 1, which implies BX plus AY is equal to AB. Now that means BX plus AY minus AB is equal to 0. This is our equation number 1. This form is called the general form of a straight line, standard form of a straight line. Now distance of this straight line from the origin is given as P. Now P equal to distance of equation number 1 from the origin, and we know the formula, that is modulus of B into 0 plus A into 0 minus AB divided by under root over of B square plus a square. That means this is ab by root over of a square plus b square. P equal to this. Now do one thing, make it square. So that means, okay, I'm now rubbing this portion. I'm rubbing this portion. Okay, so make it square. Squaring both sides we have p square is equal to, so square of this side, that means ab by under root over of a square plus b square whole square, which implies p square is equal to a square b square by a square plus b square. Okay. Now find 1 by p square. So 1 by p square, if I do the reciprocal of the left hand side, it will be the reciprocal of in the right hand side. So it will be a square plus b square by a square b square, which implies 1 by p square. Now the right hand side can be written in the form a square by a square b square plus b square by a square b square. That means almost we have completed the question. 1 by p square is equal to, now from we can cancel a square. So 1 by b square plus, and here we can cancel b square, that means 1 by a square. So 1 by p square equal to 1 by b square plus 1 by a square. Now just rearrange it. That means 1 by p square is equal to 1 by a square plus 1 by b square, and hence the proof. Okay. Okay. So this chapter is completed now. And tell me, have you any problem here in question number 18, the last question of the exercise? I hope we understood. Okay. So today we have completed the straight line. Okay. So next day we'll start a new chapter. Clear? The next chapter will be the conic section. Okay. So up to next class. Bye bye.